Try again.
Mic test. 1, 2, 3.
Say it again.
Mic test. 1, 2, 3.
So the handheld mic is for the room, and the lapel mic is for the live stream. But I don't know if we'll be able to use the lapel mic. Just a second.
And then like they'll be like, oh, you know, planting.
Okay, guys, this stream is live and up, and we have audio. So whenever you'd like to begin, go for it. He wants to start at 12:15.
Yeah.
Okay. So I'll go ahead and kill audio again. Hello, hello.
everybody. Welcome. Is how many people actually been to our IBM's city teams events before? Is that first time you're here? Anybody his first time? First timer? Welcome. And for people who return, welcome back too. We're from IBM, the San Francisco city teams. Max is our manager here. I'm the program manager. My name is Juan Jian. Welcome to our workshop. I'd love to have you guys providing more feedback. Logistically wise, we'll talk about that. Mute your phone. You know what a restroom is. And make sure there's a little feedback form that you need to do. Excuse me, before you leave. We'd love to hear you providing feedback, specifically focusing on what you want to hear more, and based on what you have learned today. So welcome, and let's start the session. Pass on to Andy and Anthony.
Thank you, Anita. Hi, everyone. My name is Andy. This is Anthony. We are developer advocates, sorry. Today we're going to talk about Kubernetes 101. So the keyword is 101. Kubernetes is a very broad topic. It can go on, and I learn something new every day working on Kubernetes. So it's a very broad topic, and this session is about 101, introduction. And we do have workshops scheduled, so that goes more into depths of how things work and your experiences, but this is introductory. And like I said, it's a broad topic, so what I'm trying to do is I'm trying to guess and cherry picking which topics can be useful to you for the future journeys you might endure. So today's agenda, we're going to basically talk about what is Kubernetes, the architecture of that, and we're going to go through a certain concepts or terminologies of Kubernetes. And then we're going through a demo because in the end, what's the purpose of using Kubernetes, right? We go through all the hurdles. What do we get out of it? So that's, in the end, we're going to see a demo. And then we're going to leave some time for Q&A. So if you have questions, please wait until the last. Now, normally we start with a couple of quiz, but I'm going to start, before we do this, I'm going to start with a trivia question. How many people know what Kubernetes means? The word Kubernetes, what does it mean? No? Okay. And do we know where it comes from, the term Kubernetes? Yes, it is. Good guess. So yeah, so Kubernetes means helmsman, the man who pilots the ship. And it's coming from Greek. So in the future, you're going to see other projects. If you stay on this project, you're going to see other projects, right? One of them is called Helms. So it's helmsman. Helms is the packaging system for Kubernetes. So instead of doing npm install, you can do Helms install. So that's one side project. Another project is called Istio. It has a component called pilot. So again, it's coming from this terminology. So that's one interesting trivia that I would like to share. So coming back to the topic, what is Kubernetes? In short, it's an orchestration tool to manage your microservices. But in terms of managing, what does it mean, right? It means provision. It means monitoring the health, and it means to scale up and scale down, both. So it can do these things. So think Kubernetes, I always use the analogy of a manager, right? When you have a startup, you have a couple of your own microservices, it's fine, right? Just like a startup have a couple employees, and a co-founder can just manage them. Now your team grows. Your team grows. You have 20, 30 employees. Now what do? You need a manager. The same thing with Kubernetes. As a developer, you have 1, 2, 3 microservices running. You're developing one of them. That's fine. You don't need Kubernetes. Now you're deploying it, right? You're deploying it. You have to do CI/CD on that. Now you need somebody to manage, or something to manage it for you. And that's what Kubernetes is. So it takes care of not only your apps, microservices, but all the logistics as well. It takes care of your networking, the volumes, secrets in terms of configuration and security, and other things like certificates, security certificates for you. These are what it does for you. And it is important to remember that even though Kubernetes, we say it takes care of these things for you, it doesn't actually control a lot of things. So underlying what Kubernetes sits on is infrastructure. And that's a different topic. So Kubernetes has to have a way to communicate with the infrastructure to actually fulfill your desire. So that's something interesting, and we're going to be talking about that in a little bit. So one thing that's interesting about Kubernetes is it's in a desired state declaration, which means you tell Kubernetes, these are the things I want, and it's going to do it for you. Unlike other tools you probably have used or have heard, for example, if you are using those config management languages, you need to get into the host and do all the shell scripts by yourself. You need to do that by yourself. And this thing will help to do these things, to do all the tasks for you, but you need to know how to talk to it. That's it. And one thing to mention is our involvement, IBM's involvement in this Kubernetes project. So Kubernetes actually is an open source project. It's not only open source, it's also open steering. We've seen many large open source projects where some large companies get involved and they are basically steering where it goes. And that's not the case for Kubernetes. Different companies, different groups can have their own voices. And we are deeply involved in many of the projects or components or side projects of Kubernetes. So on top of that, we also offer as a service, as a product, we have our own IBM Cloud services. We have our Cloud Private, and also our cognitive services. Watson is deeply incorporated into our cloud services. So you can just order a Watson service like speech to text, or you can have data mining, all those things. You can have the services bind to your cluster. Kubernetes architecture. This is, again, a tough topic because it changes a lot. It changes not by components, but by focuses. Every day there are new add-ons to the feature lists, and sometimes like the small feature at implementation actually is going to take over the larger features. So that's a very interesting to look at because the whole project is booming. It is experiencing the growing pain of any good project, healthy project. But in terms of architecture, there are a couple things that stands out. One is it has a database, which is etcd, and then it has a brain, kind of. It's called a controller. Actually, there are sub-controllers underneath it, but let's just say logically there's a controller and there's a worker. Worker means it's just a hosting node to your containers. And then in between, there's a message bus. And then it also manages the networking, volume, secrets, etc. Again, I would like to use the analogy of a manager to emphasize this. So once you have a deployment or you have something you want, you tell Kubernetes by a declaration, meaning that you tell it through API call. And then it's going to do the things for you. And then when it asks for other components that it doesn't control, like networking, volumes, secrets, etc., it actually going to use the API to communicate outside as well. But also in between, inside of Kubernetes, it's also a management worker or employee relationship, which means for every subcomponent, let's say a scheduler, or you have some add-on features, each has a brain. Each of them has a brain, and each of them has a worker or an engineer. So by that design, what you can do is you can swap out your implementation because it's hidden underneath the brain. So only the brain talks to the worker, and you don't have to deal with it. And then you wouldn't notice the difference from the user's end. Another part of the architecture is the glue of everything is the API server. So when the brain tells a worker to do something, it goes through the API. When different brains are talking to each other, they go through APIs. And then when the client is talking to your Kubernetes system, it's using APIs. When Kubernetes is talking to volume or networking, it's using APIs. So API is everywhere. It's not just for end user to access your service. It's a core of this implementation. And that is a very, very interesting design, and I would say it's a very good design because when you have new features, you just add on to it, right? You can just add on to the APIs. You don't have to replace the whole module. In terms of what this architecture, it gives us ability. So let's say you go to IBM, you order the container services, which you can get. What you get is a Kubernetes cluster. And then you go to another vendor. Your clusters, the interface will be the same. Like all the APIs you shoot, it's going to be the same. Underneath it, we can swap out some components. We can change the implementation a little bit, but you wouldn't notice from your end. So that's a very important feature that you don't have to change much. And in fact, one nice feature which is not mentioned on the slide of Kubernetes is that when you're deploying your microservices, you don't have to change your code. And that's a huge advantage because a lot of services would require you to get some features. For example, if you want security or you want encryption or something, you need to change your code. For Kubernetes, you don't. So that's very, very nice part. Now, before I move on to the next, I want to also clarify a certain things about Kubernetes in terms of what it does, and actually what it doesn't. So first of all, Kubernetes is not a message bus. It doesn't. So when you're deploying your microservice, actually you cannot rely on the Kubernetes message bus. not a build pack, meaning that you cannot rely on to build and then make sure that the libraries are all compatible, those things. So the reason we mention this is people always are comparing other tools or other platforms. So Kubernetes is not that. So let me say it directly. Kubernetes is not Cloud Foundry. It doesn't do build packs. Kubernetes is not Docker. It does not run. It's not itself a container engine. So you need to use one of the engines. Again, it can be swapped out. It's a worker for Kubernetes. Three is Kubernetes is not Mesos. Kubernetes does not do those ad hoc services. Like with Mesos, you can say, I want like a Spark cluster or what's the name of farm. Kubernetes does not have those deeply integrated into the system. So all these things are Kubernetes that's not. So that's very important to remember because Kubernetes, again, it's managing your microservices for you. And the advantage really comes at the DevOps perspective that it actually can help you a lot with the DevOps tasks. So now we're going to move to the session about the concepts. So I'm going to hand it over to Anthony and let him do it.
Hi. How's everyone going so far? Good? All right. So I know the list of resources is kind of overwhelming, but the important resources that we'll discuss are deployments, pods, and services. So what are pods? This is a group of one or more containers that are located in Kubernetes. They are the smallest unit that you can deploy and manage in a Kubernetes cluster. And there are also several types of resources that helps manage them, such as deployments and services. These define how to expose your app as a DNS entry. So let's say you name your service local MySQL, and your port is 3306. You'll access that MySQL service at local MySQL 3306. And services are query-based selector to which pods apply. So you'll need to tell which service to connect to the pods. And deployments. Deployments define as desired state of deployment objects. So let's say I want 3 pods, then you'll specify in a deployment that you want 3 replicas. Then that deployment will maintain those 3 pods. And what I'll show you here is a very simple coffee application. The application mimics a web app that lets you order coffee online. And the web app has a front end that shows you a user interface and a back end that processes the orders. And the goal of this demo app is to show you how we would interact with the Kubernetes API and most importantly, how we deploy an application in Kubernetes. So I'll show you the UI first. So first, let's go to the configuration API. Configuration file. So this is a YAML file, much like a JSON. So we specify which kind of resource we want to apply to the database, to the etcd, and we specify the kind is a deployment. And for containers, has anyone worked with or played around with Docker? Yeah, so I'm using a Docker image. It's pushed in Docker Hub, and the front end is at port 3000. And for the service, you'll see that I have a selector. The app is Coffee app. So in my template, the pods that will be deployed is going to be selected here. And so how do we use this configuration file?
Is that a Kubernetes configuration file or Docker Compose?
It's not a Docker Compose. It's for Kubernetes, specifically for Kubernetes. So I know that Docker Compose also uses YAML files.
Can you go back to where the GitHub repository is?
Oh, GitHub repo?
Slides back.
Right, this one? You don't have to follow, but yeah. So let's move on to, I'll show you the GitHub repo. So you can view the most used commands for Kubernetes. So kubectl is the way how we interact with the Kubernetes API. And for creating our resources, we use kubectl apply. And let's deploy our app. So you see that I have a service created and a deployment. This Coffee app YAML file is a combination of those service and deployment configurations. And I also have another YAML file for my backend. It's the order API that would process the order, but instead of storing the orders in a database, I've configured it to send it on my Slack channel. So let's apply the configuration of our backend. How do we access our application? So there are two ways, either the external IP or the node port. We can view the node ports in kubectl get service. This would show you the node port, and if you have your Kubernetes worker IP, you can access that IP, then access the port. But since we have load balancer here, we can access it through that external IP. And port 3000. There you go. So let's say we order 3 mochas and 1 Americano. And I should have received my order. And that's it. That's the app. And what I want you to show is how do we scale them. You can scale them either manually or automatically using an autoscaler. So for, let's say there are a lot of people ordering at the same time and we want to scale our backend to process more orders. So what we're going to do is kubectl scale our deployment, which is the order API, and we'd want 2 replicas. Kubectl get deploy shows you the deployment and found out that the name is order API deployment. And you'll see that it says it's scaled. And going back to the list of deployments, you'll see that there are 2 replicas now available. And to view the pods, which is the smallest unit in the cluster, you'll see that they have 2 pods of our backend. And that way, we could process more orders. And for auto scaling, what we'd want to do is, let's say multiple people are accessing the app at the same time, and we'll want to scale them automatically based on the number of users, based on the CPU percentage it got requested. So kubectl auto scale the deployment, which is coffee app deployment, and we're setting it at a minimum of 1 pod and a maximum of 10 pods. And to view your horizontal pod autoscalers, you do kubectl get HPA. It would take time to detect the autoscaler for the pods, which is the coffee app deployment. And it would take about a minute or two. We could.
Generating traffic.
No, not yet.
Okay.
It should. Now it knows that there are 0%. The CPU percentage is at an average of 0%. And that's because no one's ordering. And what we'd want to do is generate traffic. And we'll generate the traffic doing the curl loop to the front end. And I should receive multiple Slack messages. And we could watch the horizontal pod scaler increase some load in the CPU percentage. We could add -W to watch the changes in the Kubernetes deployment. And it should take around 1 to 2 minutes, as this just computes the average of CPU percentage, not the current status. And what that should do is once the CPU percentage is 20% or above, it should auto scale it to add another pod or increase or decrease. So what it should do is increase, but once there are no users that are ordering, it should automatically scale down to a minimum of 1 pod. So now it detected that it's 56%. And let's look at the number of pods using kubectl again. And now you see that it made 2 more replicas, so there are now a total of 3. And it just created 20 seconds ago. Let's look at the HPA, and now it says 3 replicas. Let's cancel this one, and that's it. And this, once around 3 to 5 minutes, it should automatically scale down to a number of 1 pod. And another cool thing about the deployment is, let's say we have a backend of the order API. There are 2 pods, right? And you see that there are 2 pods, but let's say one crashed and the pod got deleted. Let's simulate a deletion of pod, and kubectl delete that pod. It says it's deleted, and our watcher would now run 1 more pod, this pod. So that deployment is our desired state of our application. And we have watchers watching over them so that it would maintain that number of replicas. And to delete the Kubernetes resources, we could use the same configuration file, kubectl delete order API. Now, if you look at the list of deployments, you'll see that we don't have the deployment anymore. And since we don't have that deployment, our pods should also get deleted. And that's it for the demo. And now we'll move on to IBM Cloud Container Service. And I'll move it over to Andy.
All right, so this is just an introduction on what this container services offer. Like I said, IBM Cloud Services has many different parts, and one of them is container services. So container services, we have different modules or pieces that we are offering. So these are the features. You can get a better understanding of it once you log in and get a trial account. The trial account is free, and it's good for 1 year or something, or 2 years. I don't remember, but try it out. It's pretty good. Another thing we want to talk about is what we call the code patterns. Patterns are recipes to try out. Like you can just try out these examples, do a git clone and try out these examples. It also has other steps in the README, so you can just follow them and get a sense of what the technologies look like or feel like without spending too much time of figuring out what app should I use, how do I try out this feature. So this is a good way to try out the technologies. So now it's a fun part. Questions? Yes, please.
So in the demo, when you're running the kubectl command, are you deploying the front end and back end locally on the laptop, right?
No, that kubectl would communicate on the Kubernetes API. And in this instance, I'm using a provisioned cluster from IBM Cloud.
Okay, so you're connecting to the IBM Cloud.
Yeah.
But are the Node.js apps in the container as well?
You mean the images, Docker images?
Yes.
They're pushed in Docker Hub.
Okay.
And downloaded by Kubernetes into the cluster. So it's running inside of IBM. So the whole thing is this: kubectl goes with the environmental variable. That environmental variable you can acquire through your command, like IBM Cloud Services command. You can get environmental variable. That's going to tell kubectl to go to the IBM Cloud or whatever cloud, because kubectl is a Kubernetes API. Yeah. So you can point to your other services other clusters as well, as long as you set up the environmental variables properly, and then it's the Kubernetes is gonna pick up that image you specified in your deployment script, and pull it down into the cluster and run it from there.
So, but kind of like an intermediary step would be interacting with Docker Hub.
Yeah.
Yes.
We don't see it
Docker
because
images.
Kubernetes is handling all that.
Yeah.
Yes.
They manage it. It's container orchestration too.
Okay.
And it doesn't have to be a Docker Hub. It can be your own repo of containers as well.
Okay.
In fact, IBM has a container service, has a container registry, so you can have your private repo and it's a secure repo. Yeah. Other questions? Yes, please.
Is it possible to configure dependencies? So if you have ramp up, it requires API. When you drop API, so your application no longer runs. So is it possible to make a dependency and after start APIs once you start application or something?
That comes twofold. So first, that dependency is done by how you design your microservices. Right? If you have two microservices, they need to talk to each other. That dependencies should be addressed in your code.
Yeah.
That being said, there are things such as how you bind a service, or how you bind a secret to your microservices. So these things are configured, and it's a standard configure, I believe, right now in across different platforms. So you just need to provide that the configuration at runtime, and it's going to be picked up. So you don't have to say, for example, if you have a microservice, right? You have one container wants to talk to a database. You don't need to hard code your IP address. You don't need to hard code your port, but somewhere you need to store your credentials somewhere. But that's all manageable through Kubernetes. Yeah. Other questions? Security considerations. Yes, so Kubernetes supports different levels of, and with different add-ons. For example, I'll give you one example. The project Istio is managing the cluster, so it secures the traffic between the pods. So when you get Kubernetes by default, it only secures traffic. Let's say you want HTTPS. It terminates at your ingress level. So you're not getting into, within the cluster, the traffic itself is not secured, but it does have authentication and authorization. And now the role-based authorization, RBAC, yeah, is getting to be the mainstream. So by doing that, you can secure a lot of things by default already, but with add-ons such as Istio and other projects, you can also secure the pods, their communication as well. Yes, please.
So since you titled this session as Intro to Kubernetes,
Mm-hmm.
you help me understand how it's different from Docker.
Cool.
Docker containers.
Docker containers. Okay, good. I like your question. If you ask me how it compares with Docker Swarm, it'll be difficult. But Docker containers, so first, Docker has two things. One is the image, right? It's a Docker image. A second thing is Docker has an engine, runtime engine. Kubernetes has neither of them. Kubernetes is using a runtime, but it can be a Docker runtime or it can be something else. In fact, when CoreOS started the project, they were using Rocket. So it's a Rocket image, it's a Rocket engine. Now they swapped it to use Docker. So Docker is just one of the workers I mentioned that can be swapped into and actually running these containers. They're not actually, they're not in the management layer, so to speak. So again, Kubernetes is the manager and Docker is the worker in this case.
It's related. I was going to say, just related to that, the Docker has its own orchestration.
Yes, Swarm.
Okay.
So Swarm is, good thing is Swarm is part of it is like free or open source as well, so I can talk about it. So Swarm is mainly for developers. Like you want to try out your things in the environment, but you don't have a cluster. That's good, but any scalable, if you want any of those features, Swarm is not up to par with Kubernetes. But you can definitely try it with your, like, we sometimes do things using Compose or something. Yes, please.
To what degree can you configure which workers the controller will forward data or request to?
Yeah, so
Because like default, it kind of just like sort of
round robin.
It evaluates which ones are, I don't know, have enough memory to do a job or something.
Yes.
But that's an obstacle I've come up. So
Mm-hmm.
it's like a practical question, like how can you like control which workers get the job?
Yes, so that actually goes down to who's offering. Like if you are deploying it in a private cloud, you have that privilege to switch it out, swap it out. So there are different schedulers. Kubernetes has a default one that when you download, you get one. It also has enterprise scheduler. You can use that. And then each vendors kind of have their own schedulers as well. But I have to tell you, it's not, the whole scheduling thing is still under development. If you look at their roadmaps for 1.9 and beyond, they're still working hard on this. Yeah. Any questions? Yes, please.
What kind of metrics can be used for scaling instead of CPU?
Oh, what other criteria can we use other than CPU?
CPU, I haven't explored that much, but I think memory, we could do memory.
I think memory, CPU usage, basically these compute resources, but the others we need to check. But it is really based on the resources you consume on the node.
I think you need to find a custom one.
Yeah.
Yeah, you can have your custom ones.
So IBM's container service is primarily Kubernetes, not Docker? What you just showed to us, whatever picture.
Yes, yes. So Kubernetes. So when you say Docker is, definitely we're not using Docker Swarm, but we do have enterprise Docker solution. I believe it's for the mainframe system. At least that's what I read. If you go on to IBM Cloud Platform, you can get by default this Kubernetes services. Yes. Other questions? Okay, so see, this is a problem. We still have 20 minutes to kill. So instead of you ask me questions, yes, please.
So, you said you're contributors to Kubernetes. What are the next big phase for the project? Are there new areas that Kubernetes is going to expand into?
There are a lot of them. I just cannot keep track of them. The Kubernetes community is growing, and there are so many projects going on, and there are different small companies trying to get in as well. So mainly, I think it depends on which one you're focusing on. Like they have subgroups, and I only follow a couple of them. I don't follow all. All right, let me ask you guys some questions then. So we talked about pod, right? So what's the difference between a pod and a container? Anyone want to try?
So pod is typically virtual machine, like a virtual machine of hardware and container alongside pod. Continuous
Set of containers.
Yes, so pod is a set of containers, but it's not a VM or anything. It's just a grouping a couple of containers together. So that's one of the things, you design this way and then it goes that way. So in the beginning, I guess, long time ago, 2 years ago, when Kubernetes were trying to, when Core OS was trying to build Kubernetes, they had this pod idea where you have different containers in a bundled environment. For example, you have your web app, you have your backend, you have your database, all three in one. So you have security. Like you don't have to give them IPs. They are talking through the ports, etc. So that's their design. But then it turns out it doesn't work like that. So you have your web app. It shouldn't be in the same pod as your backend, because your front end and back end might take different loads. And when we do things like scaling, right? If you're scaling both of them together, you're wasting your resources. Yes, go ahead.
So like the example you just gave us, you have the front end, you have the back end, and you have the database.
Mm-hmm.
When you scale a pod, you're scaling all the resources in that pod. So you're scaling the front end, the back end,
Yes.
and the database.
Yes.
Where sometimes you just want to scale the back end.
Exactly. So now they took it out, right? So now it's I think they changed that design a little bit. So now normally you have one type of service in one, one type of microservice container in one pod. And then you have other things you can put into the pod. So they still keep the pod structure as a minimum. They don't go to the containers. So like, for example, if you want to have, what if you want to have a load balancer in front of your pod? What if you want to have a proxy in front of the pod? So these things, you put inside of the pod, and it's easier to manage. So that's one of the features they kept, but it has been different from the original design. So it's just an interesting thing. Yes?
If a pod has one container, is it also just a container? It's still a pod.
It is still a pod. Yeah, it also has a wrapper. Like all the wrappers are still around it.
There's no way to deploy just a container.
Yeah.
Like a pod is the only way to deploy a container. That's the
Exactly. Exactly.
But the pod can have different types of containers.
Yes, it can. By
Identical.
exactly. By design,
So when
it is.
it replicates with additional pods.
Yeah.
When you say replica, it will create
Yeah.
copies of the pod or
Yeah.
copies of the container.
Copies of the pod. Yeah.
How can I add the container? You say the existing app has all the container it needs. If I want to add new application and add to the pod, how can I add that?
You specify it in the YAML configuration file, in the template.
So it will replace the entire pod, right?
You need to do a redeploy, but it's going to replace it. Redeploy, and it's going to replace it. All right. Another question I have is, why do we need a service? We just talked about pods, right? Why do we need a service? Anyone want to try?
What do you mean by service?
In his demo, we were doing a deployment script and a service script, right? So service actually declares a service, declares your pod as a service. So why do we need a service? Yes, please.
It's an endpoint that you create to communicate with the pods. So it's basically a pointer, a DNS pointer to the pods.
Exactly. So service has different benefits. One, it's more stable to say because pods can come and go, and then as a reference point, just like he said, as an endpoint, service will always be there. So service is going to be a IP. Once you create a service, you're going to have an IP address, and then you're going to have a DNS address within the cluster. And also, service enables communications with other services, like your front end and back end. They're in different pods, right? So without service, they cannot talk to each other. They only talk to each other via services. So front end has to talk to front end services, and then go to the back end service and talk to the back end pods. So services is their kind of a proxy or reverse proxy in that sense. So you can communicate, and also service also manages the communication between the service endpoint to the pods, to individual pods, since they come and they go, and they were just they can also scale up and down. So that's what services does. All right. Any more questions? Yes. Yes, those are all configurable. So by default, it has checks. By default, you don't have to worry. But if you want to have special checks, you can definitely configure them through the API. So there are certain things that's not under control of Kubernetes, so it cannot check. But everything that's under its control, it can definitely check for you, and you can customize it.
Also, you mentioned that
Without add-ons, it's not encrypted. You can have add-ons, like I said, still one project is managing the traffic inside. So you can have TLS, mutual TLS within the cluster.
Well, if you configure your container or your pod with SSL or 443, it will be encrypted. So it's up to you.
Yeah.
So how strong is the Kubernetes adoption in IB cloud, if you can tell us? What's the growth rate, on the number of customers or revenue, however you can tell us?
You get me. I'm not, so we are the developer advocates. We are not sales or marketing. We don't get familiar with the numbers. But I can tell you that Kubernetes is definitely the main growth point for our cloud services right now. Just by the sheer number of requirements we get on technical questions. That's how I get the hint from, because I don't have the numbers, but like on other channels, Slack channels.
Metric that you
Yeah.
You have, that gives
The numbers I have is in Slack channels. This Kubernetes users, that channel is the busiest that I can tell you. So that's definitely an indication that we have a lot of customers and it's growing really fast.
Last, the networking portion, like the IP assignment for the individual container versus you assign at the code level or at the container level, and then when you scale it out, the entire strategy was handled by Kubernetes or not, or we need something external to provide it?
Can you rephrase the first part of the question? I'm not.
Networking strategy being provided by the Kubernetes, because when you scale in or scale out, or when you adding the services, it requires the IP assignment or individual identification to talk to each other. So how does it going to work it out in this?
Yes. So again, it's a manager and worker thing. So Kubernetes has its default networking implementation based on Flannel, which doesn't. It's mainly IP tables plus private IPs. So it doesn't do many things. IPAM. If you want to have an IPAM service, you need to have your own. In our case, we use Calico, which is going to assign us IP.
So it is inbuilt with the Kubernetes or external?
External to Kubernetes, but then it can be swapped in. So it can easily be integrated with our existing services.
Yes?
What determines the speed of scaling the nodes? Does it seem like it took some time before it scaled up and down?
Yeah, it usually takes like a minute or two for the target CPU to increase.
Is it something you can define? How fast it scales?
Oh, how fast?
Or is it only the limits, let's say 20% versus?
Yeah, you can customize it or 20, 50%.
No, he's talking about the responsive time.
If you want something to scale faster, is that possible?
For our configuration, we can.
So
Depends
your
on
question is more configuration as opposed to CPU time, and you also want within 5 seconds or 10 seconds?
Yeah, what I'm thinking about is, let's say we hit the 20%, now we want to add a pod. It seems like it takes some time to get the new pod up and running. Is there anything you can do to make that happen faster, or is that up to Kubernetes to?
So if you are waiting like the 20% or 50%, it's 50% stabilizes, then the new one kicks in.
It depends on.
50% just suddenly drops. You don't want another one to come in, so stay 50% stabilized, another one is on.
No, I think it depends on the algorithm to decide when to add. Because the 20% is based on the mean percentage for the last minute or two. So it keeps calculating it until it's getting stable. If you say the window is smaller, like if it spikes within 10 seconds, you just do it, then definitely you will see that pod coming up really fast. Because the difference between a replica pod and a new pod is replica pod you don't need to download the image, right? It's already there, so you can just make it up and running real fast. It's really the algorithm that's.
So to adding my
Mhm.
his question, if we he said 50%, I understand. If we want to scale, but it requires that memory, CPU, all the so that additional environment provision, how you integrate, or Kubernetes have a good knowledge about how gonna add the resources to the services or not? No?
No, that's out of the scope of Kubernetes. So for the infrastructure layer, it should have a monitor on Kubernetes. It has to monitor Kubernetes. Oh, the node is using most of CPU. Let's add another node. Because you don't like.
But how does the Kubernetes will be aware that something I really need extra? Or
No, it's not.
How does that infrastructure monitoring will inform to Kubernetes? Oh, we need to do in a certain fashion.
Kubernetes only knows what's inside of the cluster. So it's not aware of what's outside of it. So if you're not providing the resources, it cannot monitor it, right?
No, but how does it know? How does the both system will sync it out when you scale your application? And the Kubernetes is like more internal. Some kind of mechanism should inform Kubernetes. Oh, we need to scale in that fashion, or we need to add more resources on node, or etc.
Okay.
So there must be something, right?
Yes. So right now, from what I know is you need to manually scale out your nodes. If you want to add nodes to your cluster, you have to manually do it because you're paying for it. So I don't know if it's enabled like automatically
So my
scale up your nodes.
Auto-scaling. Let's say
Yes.
I'm sleeping and then I don't want to do anything.
Mhm.
My scale application should be auto-scale based upon the request I'm getting,
Mhm.
and then descale based upon the request I'm getting.
Yes.
So is the like you from your you said we have to manually add, and
Yes.
then I'm human. I don't know what's going on in the night or any like people are very remotely.
Yes.
So to scale, auto scale or descale in terms of resources, there must be something, and that was one of the intention today to more about knowing about Kubernetes.
Okay. I get your question. So you're saying that even for node services, for nodes, right? Not just for pods. For node, it should auto scale. Yes, that's what you're saying. So like I told you, from what I know, I don't know about the technical part of it, but from the reality part of it, the scaling you have to do it today manually because it has something to do with billing. You're paying for the nodes in the cluster. So if the system just do it without notifying you, you're paying more. And you can challenge that bill.
But he can have an external auto scaling or auto monitoring of his Kubernetes piece.
Yes,
And then
yes.
that would be the one that will provide the resources, the infrastructure resources
Yes.
for your internal Kubernetes.
Yes, you can always monitor it. You can always monitor it, but the decision today seems to be manual. Yes. All right. I guess we are good for now, right?